Hi everyone. Today we worked on 412 and so I forgot to record it in class, so I'm going to go over this right now, and it might be a shorter version. And you can just enter the answers for the warm-up, the check-in, and the exit as we go. Okay, so we're looking for a faster way than to build everything with tiles. That's our goal. And so we noticed a pattern last class. We noticed that the product of the diagonals is always equal. So for example, on this one, 10x squared times 14 is 140x squared. Negative 35x times negative 4x is also 140x squared. So we kind of said, hey, does that work every time? 3x squared times 8 is 24x squared. 4x times 6x is also 24x squared. So it actually does work. If you look at if you set things up a certain way, if you set it up, we're dealing with quadratics where the one that has an exponent of 2, x squared term, times the constant. Your constant is your number that doesn't have a variable. If those are in opposite corners and then your x terms are in opposite corners, the product of these two terms is always going to be the same as the product of these two terms. So that was just a pattern that we noticed. And then we said, okay, how can we use that pattern to make things go a little bit faster and not have to build everything with tiles? So we kind of did this one as a warm-up today. So you can do 412 A as the warm-up. Enter that answer as the warm-up to get those points. And then 413, we worked on together. And the first one says to build it with tiles. So I'm going to do this just because I think some people will benefit from this. So I'm going to do part A with you. And I'm going to ask you to write this in your notebook. So 2x squared plus 5x plus 3. So this is, let's see, 413A. And I'm going to build this with tiles. So I'm going to get, the tiles are already there, which is nice. Okay, for the E-tool. So I'm going to make a rectangle with these tiles. Not too difficult for this particular set of tiles. Okay, so here's my rectangle. Let me move these up a little bit. Okay, and I'm going to write this as a product. So remember that if you're not sure what the dimensions are on the, main Schoology page, if you scroll down to where it says resource pages and click on tiles with dimensions, you will get this document here. So I'll go ahead and do that. Okay, so here's all the tiles. It doesn't have the area of each one, but it does have the length and width. You can probably tell which tile is which. This is the X tile, this is the Y tile, this is XY, this is Y squared, this is X squared. Okay, so I'm going to write the area of this rectangle as a product, and the way I'm going to do that is I'm going to figure out the length of each of these tiles. So this is the length of the X squared tile, which is right here, is X. So that length is X. So is the width. The width is also X, right here. Okay, and okay, so this would be x. And then for the x rectangle, the short side of that rectangle is 1. So let me add that. Whoops. Close that out. So this is 1, this is 1, this is 1, and this is 1. And there might be other ways to build this rectangle. This is not the only option. But if you were going to write this as a product, it would be, this side would be x plus 1, and this would be 2x plus 3. So this is the sum, and the product is x plus 1, 2x plus 3. These are factors. These are factors of this quadratic expression. Okay, and then we said, okay, what if we want to just use the area model here to factor instead of always building with tiles? Okay, so we have this expression right here, 3x squared plus 10x plus 8. Okay, so Miguel says, I'm going to try this using an area model. Maybe I'm tired of building with tiles, or I just don't have tiles. So I know if I had tiles, I'd put the 3x squared tiles together, right? And then I would put the 8 unit tiles together over here. And I know I would have 10x tiles to work with. So I know together these are going to be 10x tiles all together. Okay, so it says to, basically it says finish this rectangle and decide how to split them. All right, well, I know that this product has to be the same as this product. So I could split up 10 lots of different ways, right? We could do 1 and 9, 2 and 8, and so on. But I know that this product, 3x squared times 8, 24x squared, that's going to be the same product when I multiply these two terms. So I'm looking for two numbers that when I multiply them, I get 24, but when I add them, I get 10. Have you figured it out yet? What can you multiply to get 24, but when you add it, you get 10. So that's why you saw the multiplication chart. So if you're looking for two numbers that multiply to give you 24, here's the answer right here. It would be 6 and 4. And there's other ways to get 24, 8 and 3, 2 and 12, and so on, but those don't add up to 10. So we are going to use 4x and 6x because we know that this product has to be the same as this product. And this product is set. We know that's going to be 24x squared. This is flexible because you've got 10x tiles to work with. Okay, so the idea here is you're going to move away from using tiles all the time and you're going to start using an area model and a diamond. The diamond is just a way to organize your what we were just talking about over here. And I'm not going to finish this because I know if you're watching this, you're probably trying to get these points in, and you may also just really need practice with this whole area diamond procedure. So I'm going to move on to part C. And this one, I want you to write it in your notebook. This is going to be the check-in. Okay, so draw your area model. We know that the x squared term and the constant have to go in opposite corners. Well, they don't have to, but it will make our lives easier if they are in opposite corners. And now we're going to add the idea of this diamond. So we know that this product is the same as this product. So we're going to put that product in the top of the diamond. If we had been in school in real life, you would have done a bunch of these diamond problems for homework, for written homework. But that just didn't happen. So we are going to put the product on the top. So 2x squared times 6 is 12x squared. So we know that this product, whatever this is, it's got to be 12x squared. But these two missing pieces, if I was building this with tiles, I'd have 2x squared tiles here, 6 unit tiles here, and I'd have 7x tiles to divide up, right? So that goes at the bottom of your diamond. That is your sum. So you are looking for two numbers that when you multiply them, you get 12. When you add them, you get 7. Have you thought of it yet? Well, can you multiply to get 12, but when you add it, you get 7. Okay, 4x and 3x. 4x times 3x is 12x squared. 4x plus 3x is 7x. So this is kind of just to get your missing terms correct. You know they have to multiply to give you this. You know they have to add to give you this. Where does this come from? This is the product of your x squared term and your constant. This is your x term, the x tiles that you're dividing up. And then once you have that, just put those in the missing parts of your area model. Now I'm going to go ahead and finish this one. What can I multiply to get 2x squared? Well, that's got to be 2x and x, right? So it does matter where 2x goes, and it matters where x goes. And this is what you're going to type in for the check-in. Your check-in is going to be the product. So because 2x is a factor of 2x squared and 4x, I'm putting 2x on the bottom. I could not put it here because 2x is not a factor of 3x. I can't multiply 2x times something and get 3x. Not times an integer anyway. Okay, so 2x has to go here. X has to go here. 2x times what? And if it helps, Raina was putting the number up here. That's fine. You could put 2x up here and then say 2x times what is 4x? Well, that's got to be a 2. And then if it helps, you can put the x over here. X times what is 3x? Well, that's got to be a 3. And then 3 times 2 is 6. Now, you really just need the length and the width. I usually just do the length and the width. But if it helps to put that term over across from where it is to help you figure out that other missing term, go for it. Okay, so my product here is going to be x plus 2. This side is x plus 2, and then this side is 2x plus 3. That's what you're typing in for the check-in. So I had given some time for people to try it, I think. Or maybe it was the next one that we did as the check-in. Okay, let's do the last one as the exit ticket. So your exit ticket is going to be 4-14. And let's see, it gives you 6x squared plus 17x plus 12. So I want you to try, we actually did this one together and I made a different one, the exit ticket. So I do want to show you this. If you go to the main Schoology page in that purple resources page folder, you have this document, Factoring Quadratic Expressions. This is in the ebook. And these are some very helpful math notes. It just walks you through the process step by step. So if you're like, wait, what do we do after that? Here it is right here. Okay, so I want you to try, and I want you to pause the video and try and do this one using that area diamond model. Now you've only had one to practice with. And since you're making up these points, if you're like, I don't know how to do this, you can just keep going with me. But if you feel like, okay, I can do this by myself, pause the video, try it and then just watch and see if you got it right. Okay, I know these two terms are going to go in opposite corners, and I usually do the lower left and the upper right just to have some kind of pattern. Okay, so I know this product and this product will be the same. So what is this product? 6x squared times 12 is 72x squared. That's the product. We use product and sum a lot in these problems. This is the area written as a sum, and we're writing the area written as a product. And then we also have product and sum in the diamond. So there's a lot going on here. Okay, now the sum, and I'm just going to reference these notes. If you look at these notes, see how it says place the x squared term and the constant of the quadratic expression in opposite corners. So that's what we just did. Determine the product of the x squared term and the constant term. Place this product in the top of a diamond. So that's what we just did. We multiplied those two. We put that in the top. Then we put the x term from the expression in the bottom, the sum. Because if we were building this with tiles, we would put 6x squared tiles here, we'd put 12 unit tiles here, and then we take those 17x tiles. Well, I didn't tell you had to do it that way. I would have just said, make a rectangle, right? You would try and make a rectangle. But if I said, let's keep this here, let's keep this here, you're going to have to split up those 17x tiles. So you know that together, these two numbers are going to multiply to give you 72, because the product has to be the same as this product, but you know they're going to add to 17x. So what two numbers can you multiply to get 72, but when you add them, you get 17? Well, guess what? There it is right there, 8 and 9. That's the fun part. It's like a little puzzle. What can I multiply to get this? But it adds to this, 8 and 9. So 8x and 9x are my missing terms in my area model. And I realize you might be kind of lost in the procedure, but the more you practice with this, the easier it's going to get, and you're going to start to hopefully make important connections and be able to kind of visualize what we're doing here. Okay, now the exit ticket, I want you to write the product. So I want you to try to get that part by yourself. I want you to try to get the length and the width by yourself and type that into the Desmos activity.